Now I really like this question. The reason why is because, I mean, it seems like they're handing it to you, but then you run into problems, okay? Now, what I'm going to do first is I'm going to try and approach it the way I think a lot of you have approached it. I'm not going to finish it off, okay? I'm just going to get to sufficient enough a point to show that there are problems with the way that you've solved it. They're not insurmountable problems, but a lot of you have just seen the problem and quietly ignored them and kept on going as if they weren't there, okay? So, here's the way a lot of you are doing it, okay? You see this, obviously you need to work out du on dx, right? You get your 2x, okay? But then, you realize there is a problem, okay? When you're going to substitute these pieces into here, right? No problem getting rid of this x squared. That's okay, because x squared is just u plus 1. I should write x squared equals u plus 1, okay? But then you're like, what do I do with this x? I don't have an x here, okay? Now, some of you have resorted to this. You've sort of said, I have a dx, okay? So you sort of do this on 2x. I think you've done something equivalent to that, okay? Now, sorry, wait, is that where's my x? That's dx, okay. Now, this will sort of land you the right problem, but it sort of does a bit of a no-no in that the whole point of using a substitution is to get rid of all of one thing and replace it all with another thing, okay? And you've seen where that mixes up when you have problems, particularly when you have boundaries, right? It's a big no-no to change some of it and not change all of it. And if you can't change all of it, you can't properly use the substitution, okay? Now, others of you have also tried to say, well, okay, fine, I don't want to put an x in at this point, right? I'll get x in terms of u. So you've gone over here and you said, oh, actually, you've gone over here and you said, I don't want x squared, I just want 1x, okay? So you said this. Okay, now we've been in inverse trig long enough that you know you're lying to yourself just a little bit, right? Because you're like, well, there's a plus minus there. But I don't want there to be a plus minus, so I'll just pretend, you know, he's kind of like at family gatherings, it's like that uncle who no one really talks to, you know, we just ignore him. Just leave him in the corner and don't disturb him and he won't cause any trouble. But you can't do that, can you? You must resolve this plus or minus somehow, okay? So, I've identified two problems with this way of doing it. Okay, number one, you're mixing up variables, bad idea. Number two, you're ignoring part of your solution. Okay, so the question is, how else can I do this? How else can I do it? Well, here's what I would suggest. The reason why this is a problem is really here. This is the crucial point. Okay, it's the d on dx that's giving us issues. Okay, now most of you have ignored the fact that I can, rather than mucking around with this stuff, I can work with my integral before I do my substitution. For instance, I can say if I want a 2x, I can put a 2x there. If I do it to the top, just got to make sure I do it to the bottom, right? Have I broken any laws? I haven't mixed any variables. I haven't screwed over any plus minus stuff, right? So far, so good. And I've got the 2x that I wanted, okay? Now obviously, that changes this down here, doesn't it? So you get 2x on, what's this going to be? Becomes an x squared under there, doesn't it? So that'll be 2x squared minus x to the 4. Now you're like, that's created a new problem. Now I've got an x to the 4. But that's not nearly as much of a problem as an x is. Because x to the 4 has no problems with sign, right? He's going to be u squared plus 2u plus 1. No plus minuses, okay? Going up in degree is much safer than going down, okay? So now I'm in a position to do my substitution. I know what 2x is. I know what x squared is. I know what x to the 4 is. Let's do it. This 2x dx just becomes 1 du. Okay, there you go. What's going to be inside here? It's going to be the square root of, I probably haven't given myself enough space, have I? 2 of these minus 1 of these. Sorry, u squared minus 2u minus 1. Can you see what's going on? Let me put the du in the right spot. Okay, my 2 u's, they cancel. And that plus 2 minus 1 becomes 1. So I'm left with 1 on square root of 1 minus u squared. And you can see where to go from there. Okay, so you end up with, I'm going to skip one line and just go straight to substituting out the u and get the x back in there. Okay? So, I'm not finished yet though. This is what's great about this question. It raises some interesting questions. This was the hard way to do it. There is a sneakier way and a much faster way. Okay? This was hard because of all of this algebra business that we had to account for. Okay? But think about how much you are handed about the question immediately when they say this. The whole point of using a substitution is that it's going to appear somewhere in your final answer as an inside function. Yes? Okay. Otherwise they wouldn't give it to you. Now, therefore, you know this in advance is going to appear somehow, right? Then you have a look at this. What form is it likely going to end up in? Is it going to be a tan inverse form? No, you can already discount that because there's a square root, right? So you know it's probably going to be sine inverse of probably that. So you make an educated guess, okay? Now, the reason why that's going to be easier for you is because differentiating is 10 times easier than integrating when you've got all this mess to work out, right? So you do this, you can do this, and surprise, surprise, you get this. Okay? So if you have shown that that's the, I mean, obviously there's a couple more lines in here, right? But you show this is the derivative. If you've shown the derivative, you just integrate both sides and there you are, okay? So you see, it's an educated guess based on what they've given you. And the educated guess works. All right, one last thing, okay? One more, here we go. Shh. Some of you have noticed, at least 2 of you, that, look at this integral, look at it. Do we really need substitution to do this integral? We don't. We looked at this. This is almost on the standard integral sheet, right? Let's just get that 2 out of the way, right? Slap it out the front. You've got 2 there, but this 2, right? I want something squared here. Well, it's root 2 squared. Root 2 squared. Okay? So this is a squared minus x squared. Sorry, there's dx. Okay? So what does the standard form tell you? I've got my 2 out the front. Sine inverse x on a plus a constant. That's pretty different, isn't it? It's quite dramatically different. And my question to you is, number 1, have we done anything wrong? Okay. Number 2, if we haven't, what does that mean?